right, we are back. We are back for system acquisition and development. This is the fun block. Understanding how systems and how software is acquired and developed. Okay, let's get into this one. So when we think about this, these are some of the topics we're going to talk about: the system development life cycle, and then some of the system development models, waterfall, spiral, and some of the other ones. So when we think and looking at system development, what does it come down to? Really, it's just a set of processes. It's just a set of processes of how we can develop systems in a methodical manner. And really, at the end of the day, is to get the customer what they want at the price they want it, and also where the company still makes money and it's a reliable product. So when we think about concept development, looking at these phases, we're going to walk through each one of those. This is really at the beginning of it, is defining what it is that we want. And I'm sure we've all seen, different variations of the swing and the tree, right? So, but really, this is very important to this concept definition. I mean, if you look here, this is how the customer explained it. They wanted this Uber, in their mind, Uber swing set. However, the project manager, when he got it, this is what he thought that the customer said, and that's how he understood it. Then the engineer designed it, because the engineer's going, well, what they gave me won't work. However, I'm gonna stick as close to the plan as I can. So he propped the tree up and cut it in the middle. Now this is how the technician built it, because he looked at the engineering drawings and go, well, that's stupid. Why would anybody want to do that? And really, in actuality, this is what the customer really wanted. Okay. Now there's a statement, and this probably flies in the face of everything in business, that I totally disagree with. The customer is always right. You hear this all the time. The customer is always right. Give the customer what they want. Well, that isn't always the case. Sometimes an uneducated customer isn't always right. An uninformed customer, a customer who, haven't been given the right information, the right tools, the right knowledge set to know what they really want. I've done this many times. I've gone looking for something, and in my mind, I know exactly what I want. I need this. However, I haven't done my research to know that they've made other products way much better than what I remember or what I think I want. So I get to a store and they show me, well, God, I know you want to do this, but we have this right here too. Oh, okay. I didn't even know that existed. So me as a customer, was I right? No, until I became educated. So being able to define, concept definition is so critical, so important to this process, because this is where all the stakeholders should come into agreement. Whether it's the customer, the management team, developers, engineering. So before we launch the boat from the dock, we all have a direction that we're heading. Then after that, now we can start developing what we call functional requirements. Now, functional requirements is based on the business requirements, user requirements, system requirements. All of these things come into play with respect to that. That's when after everybody have agreed on the concept, now we can start looking at how we start developing this from a functional perspective as well as from a system perspective, what type of requirements. And then from there, we should generate some type of functional requirements document. Now this functional requirements document, it is going to have some of the specifics, but not all the nuts and bolts of the specific, but really at a higher level to tell you functionally this is how this thing is supposed to operate. Now this is when we start getting into the control specifications, which is more granularity, and especially with respect to security, because now this is when our security should start to be getting added in. Things of how confidential do we want our information system to be? What's the availability, the fault tolerances? All of these things, we should be looking at adding security in up front, what we call bake it in up front, as opposed to strapping it on at the end. So within this control specification development, that's where we're not only looking at it from an engineering perspective, but also from a security perspective. And then we go into what we call design review. So now we've got our functional requirements, we've got our control specs in place. Now we can let the system designers, the system developers start to do what they do best, is go through design reviews and start looking at, okay, now how do we lay this thing out in a modular perspective? and how do we start assigning workflows so we can start building the specific parts of a system. This is very interesting. I used to work at the Newport News shipyard. This is where they built aircraft carriers and ships for the United States Navy. I was a cybersecurity analyst there. And it's so interesting to watch them build aircraft carriers because they build these things in modules. You know, they just don't start at the bottom and build up, but they have, you know, one module is built in one set of dry docks, another module, and then when they finish, they bring all those modules together and they actually fit together, and it's amazing, you know, to watch that process. But yeah, that's where you start laying out specific tasks. You start building your teams and your work statements and all of those things within this design review phase. Now, for software systems, yes, this one we start doing code review walkthroughs. So not only are we having to develop the code, we want to review that code at the beginning because we don't want to get to the end of writing a lot of code that may not work well together. Now, this is something that happens in a lot of organizations. You know, okay, I'm the code writer and I'm the submitter. Okay, no need to double check this change list. If there's some problems, then the reviewer is going to catch it, and the reviewer gets it. No need to look at the change list too closely. I'm sure the author knows what he's doing. So they're trusting each other when they should never do that. The submitter should submit the best thing, not thinking about the reviewer. The reviewer should look at this through a clean lens, not thinking that, well, I'm sure they knew what they were doing when it came down. Whole purpose of doing that review. And now once we got it built, it's reviewed, now it's time to go into some type of UAT, we call it user acceptance testing. Is it good or not? That's when we want to bring the stakeholders back in. We've got something built. Now let's run through a set of tests to see if we can find errors, we can find mistakes, and get the right people in the room that can review and can look at this to do the right user acceptance testing. And at the end of that, once the system is operational, now we're going to be sure that we're maintaining and sustaining that system throughout its life cycle, whatever those changes. And really a big part of this is the change management process, because at some point you're going to want to update that system with new capabilities, and managing changes is it is a competency skill set all its own. Now, how do we do this within this environment? Let's look at some of the life cycle models for software development, system development. We're going to really focus on 4 models: the waterfall, spiral, the capability maturity model, and the agile environment. It's more like an ecosystem now, I guess. So the waterfall model, actually, that was developed by Winston Royce in 1970. And really what this waterfall is, that's why they call it a waterfall, because as each stage is completed, the process moves to the next phase. So it starts with system engineering, then it does analysis, design, code, testing, maintenance, and there is a feedback loop at each one of these, so that if something's wrong, it feeds back. But you see, this is a very serial process. One of the problems with that model is it takes a long time. Now, at the end, many times you get a very good product, but if you look at software development today, waiting 3-4 years to get a piece of software is almost unacceptable, because the speed of business is to the point where people want to get things much quicker. While the waterfall model is used less and less in today's environment. Now, there were some iterations, there were some updates, there were some improvements made to this waterfall model to help speed up the life cycle. And this was kind of a spiral model. So you still kind of hit the same process, but at each of these points or each of these loops, you would start with an idea. As you see, it kind of goes around, in a loop. And as you learn more about that, it goes, each iterative loop is a new prototype. So you may have prototype 1 starts here, and it goes its circle and is deployed. Then it comes back and they start prototype 2. It goes around the same circle, deployed. Prototype 3, develop, verify, and then you start planning the next phase of prototype 4. So that's how you built Tech Refresh into the waterfall model. Carnegie Mellon University, they're the ones who introduced the software capability maturity model. What it did is the intent was to improve the quality of software, and quality built into into the development based on the maturity of really the process. So you had five levels, from level 1 all the way to level 5. Level 1 being the initial level, meaning this is a very low maturity level. This is kind of an infancy entry level. Your processes are very unpredictable, poorly controlled, reactive. So that's, if you're a level 1, you are just getting your foot in the door. You're at the crawl stage. You haven't even hit a walk. Excuse me, much less run. Level 2, you're kind of in that managed stage. Now your processes are characterized for projects, but still, you're still very reactive. So you're still not mature. Level 3 is when you get to what's called define. That's where your processes are characterized for organization and it's proactive. Like I say, you're gotten more maturity, and as you get to level 4, now you get into some what they call quantitatively managed. Your processes are measurable and they are controlled. And now when you get to level 5, what we call at the optimizing level, now you're ready to start focusing on process improvement. When you're down here at this level, process improvement, we'll get there. Right now, we're just trying to get things out of the door. So that capability maturity model is one that is still used today. We still see this, with different aspects of how we develop new systems. Now, what we do here a lot now, we've moved into the world of agile. Again, and agile has almost become like a religion within itself. The agile process of how it really started in the mid 1990s, but now how you integrate tests, build tests, deliver, get things to market, get them quicker. And the whole process of here is embracing the, like I said, approaches to software development that breaks some of these rigid models where you had to do these things before something could be delivered. Build, test, deliver. Build, test, deliver. Now, there's a manifesto, yes, associated with Agile. 12 principles behind the Agile model, which it is a different mindset than what we're normally used to talking about, especially with respect to engineering, software developers, systems engineering, because engineering usually is a very methodical. You think about the engineering approaches, where you have a thesis and you measure and you come up with your different ideas about that, and you test, measure, and you're looking for things to be standard, stable, reliable before you produce. Agile kind of changes that quite a bit. Like I said, we look at the first step of that, right? Step 1, principle 1, satisfy the customer through early and continuous delivery of valuable software. Really putting the customer right up front. 2, this is a big one. Welcome changing requirements, because see, we're used to living in an environment where you give me the requirement, and these requirements, and we're gonna snap the chalk line, as we say, and those requirements aren't going to change, and we're gonna go build this thing, and I'm gonna sell it to you based on the requirements. Now, even though it took me 3 years to build it, and in that 3-year period of time, a lot of things have changed, especially with technology. I don't care about that, because I'm contracted to build you this, and you're going to get this whether you want it or not. However, the Agile Manifesto says, no, we're going to welcome changing requirements, so that the requirements are always continually changing. And that was what forces us to be able to deliver working software frequently. So instead of waiting to get a finished product that's going to take 4 years, I'm going to give you a prototype. This, part A of it, it's going to work, but you're going to get this first, and I'm going to keep updating that. And number 4, business people, developers must work together daily through the project. Again, a mindset that's different than what we're accustomed to, because normally you want to have a PMR, a program management review. You bring everybody to the table, and then once you get this pristine document written, right back here, everyone leaves. Y'all clear the room and give it to the engineers, and you go. I don't want the customer, I don't want anybody else coming back in here changing things. Completely changes that mindset. Now, we're all going to work together daily. I want to see what you're doing daily. Customer involvement, all the stakeholder involvement. Build projects around motivated individuals. Many times in this environment, you get the people that not really motivated because we've been making the donuts, cranking the same thing over and over. No, you want to bring people who are excited. Face to face is the most effective and efficient way of conveying information. Face to face, writing memos, emails, so much gets lost in translation. So we want to have that interaction. Working software is the primary measure of progress. Not saving money, not all these other things, but can we deliver a piece of software that works? That is the measure of success. The Agile process promotes sustainable development. So not only am I going to give you software that works, but I'm also going to be able to sustain that software, update that software, keep it current, keep it tech refreshed. Continuous attention to technical excellence and good design enhances agility. So if we start baking these things in, now we can become very agile. So when there's changes, we can react quickly. We're not locked into a particular design because we are now agile. Why? Because we've been paying attention to the technical sides and the design interfaces. Simplicity, the art of maximizing the amount of work not done. I like that one. Is essential. Because many times, we do a lot of work because that's the way that we've always done it. Well, why are we doing this step? That's the way that we always done it. Why would we do it any different? Reminds me, I heard this a while ago. A young lady and her husband getting ready for Thanksgiving. She had a ham, and she got the ham and she cut both ends of the ham off, threw it away, and put the ham in the pot. Her husband asked her, "Why did you do that? Why did you cut the end of the ham off?" And she said, "Well, because that's how my mom did it, and that's how I learned to cook ham. And I watched her do it every Thanksgiving. She would cut the end off." He's scratching his head because it didn't make sense to him. But he's like, okay, like a good husband. All right. So then they ate ham. One year they went to their mother's house to her mother's house for Thanksgiving. And he brought the question up. He said, "Ma'am, last Thanksgiving, your daughter, she made ham, and she cut both ends of the ham off and threw it away. I was just wondering what does that add to the recipe?" And her mom looked at her. "Oh, sweetie, you've been cutting that?" And she said, "Yeah, Mom, because I watched you do it." And she said, "The reason I did that, baby, because when we grew up, we didn't have a lot of money, and I only had one pot, and the pot that I had to cook the ham in was too small, so all the ham wouldn't fit. So I had to cut the ends off for it to fit into the pot." You don't have to do that. You got big pots now. But sometimes we get caught up into that because we're cutting the end of ham off, throwing it away, because that's the way we've seen it done for years, and no one ever steps and says, why are we doing that? So before you start cutting off your ham, look for the simplicity. Maximize the amount of work that doesn't need to get done. All right, now, the best architecture requirements and designs emerge from self-organizing teams. Sometimes our structure can be so rigid within an organization that we have talent in multiple places that we don't know about because we are just looking at a person's job title, not at what they actually know. And it says that, well, you were hired to do this, but not knowing that they bring a wealth of other background that may not be on their resume, that may not be in that job description. So let teams sometimes organize themselves, and then they will find the right talents. And the team reflects on how to become more effective then tunes and adjusts its behavior accordingly. Yeah, let the teams kind of self-manage themselves because why? They're motivated. They'll find solutions. But anyway, so these are the 12 steps of the Agile, or the principles, the Agile Manifesto. Now, can you follow all 12 of these, succinctly without ever having to deviate? No, you cannot. That's not the purpose of this at all. There has to be some levels of rigidity. Everything just can't be laissez-faire. So, but that is an overarching manifesto. So now when we look at Agile, one of the things that have grown out of Agile is CI, CD, constant integration, constant delivery, continuous development, continuous integration, continuous delivery, continuous development. What does that mean? CI, continuous integration. What we're doing here, we want to continually integrate and merge changes back into the main branch as much as possible. Be sure that these changes are validated by creating a building and running an automated test against the build. But we want to be sure that we build test as we bring new things in. Continuous delivery. You can decide to release daily, weekly, monthly, or whatever suits your business needs. So you don't have to be rigid in your delivery. If your customer needs updates weekly, you can set your automation to where you can deliver products, on a cadence that fits you and your customer. Doesn't have to be annual. It can be at whatever suits the customer. And then continuous development. So here we want to be sure that as we test, we're developing, staging, deploying, doing smoke tests, and as we integrate. So all three of these really work together. You want to continuously integrate, continue to deliver product, and then continue to develop new capabilities into that product set. So as you see, when we think about these, you hear these terms now: Agile, DevOps, DevSecOps, CI, CD. What are they? What's the difference? And are there any differences in what they really mean? So I try to throw this together to kind of help explain, some of those deltas. Okay, so when we think about the term Agile focuses on an iterative process. Here's that Agile circle. You'll see that, with the plan, design, develop, test, release, feedback. Whereas DevOps is focused on a culture of, kind of doing the racetrack. Some of the same competence we have here, but now we have development and operations tied together. We're not just in a development mindset. We're not just in an operational mindset. And another circle that fits in here is security. So now we're baking security in. That's when you call it DevSecOps, development, security, operations. So your operations and security are integral parts of your entire development process. Continuous integration, continuous delivery focuses on automation. So you see, it looks a lot like your DevOps. But however, now I want to bring automation into this so that now I can kick these things out on an automated fashion. There are certain tools, like Ansible and other tools where we can automate processes. Scripts, where I can write scripts in here now, whereas before I had humans trying to do these. Now I can script these to where it runs automatically. Like I said, Agile, human-centered design, DevOps, interconnecting tasks, and CI/CD, where we're trying to optimize integration and deployment. So you see, this Agile mindset is continue to grow and evolve within itself between DevOps, DevSecOps, continuous integration, continuous delivery. All right, so we've covered quite a few things with respect to system acquisition and development. The SDLC models, the life cycle. We kind of went deeper into Agile and software development, continuous integration, continuous development. Hope this helped you guys out a lot. Stay tuned for the next one coming up. Security and privacy. At the end of the day, this is what it really comes down to. Because if you lose trust, as an e-tailer in e-commerce, that your site is unsecure, that someone's lost money, it only takes a couple of reviews, and you're done. All right, let's get into this. So when we think about security and privacy, as we get into this, this is from Thales. Thales they do a lot. It's a big company. One of the things they do different types of threat reports and things of that nature. Take a look at this. 50% of retailers have been breached in the past year, and about 75% of those breaches, 75 total overall. So every year, we have thousands and thousands of e-commerce e-tailers whose websites, whose e-storefront have been either defaced or breached. About 84% are increasing their IT spending, and about 85% of those of the IT security professionals surveyed say that organizations are using sensitive data in the cloud. So more and more people are moving to the cloud. However, with this digital transformation, it is not the utopia. Just because your data is in the cloud doesn't mean that it's safe, or just because your data is not in the cloud doesn't mean that it's safe. So you really have to understand what's going on in this environment with security and privacy. Again, let's not get those two confused. There's a fundamental difference between securing data and keeping data private. Okay, there's certain information that we want to be sure is secured, But just because it's secure doesn't mean it's always private, because people can get to it. There's many people who can, in an organization, who can get to data, even though that data is secure, like social security numbers, credit card information. I may have secured it, doesn't mean that other people can't see it. So we got to be sure that we approach both of these the same, that we understand security and privacy. So when they look at this report, as we drill into this a little bit deeper, they say, encryption, that's a technology that's really critical to protecting data at rest, data in motion, and data in use. It's really important for endpoint security and mobile defense security. So what does this show us, right? That a lot of times the businesses, companies, really aren't putting their money at the most important places. They're not really protecting critical data at the places they should be. So, this black line at the top, like I say, this is where these are tools, these are places within our data flow that are very effective. If we're spending money, this is where we can get the biggest bang for our buck for data protection. But this shows where a lot of companies, this teal color, have been increasing their spending. And one place is right here, data at rest defenses. That's you get a lot of bang for your buck there. And data in motion. All right, we're talking about data in motion. That means that's when something is going back and forth across the internet. So if I've got a transaction and I've given you my credit card number, so when I hit enter, that credit card number is going to go across the internet to get to your website to be processed. But we want to ensure that we're using the right type of encryption so that that credit card number is encrypted with a strong, 256 bit encryption, some type of AES, advanced encryption standard, so that is encrypted before it hits the wild out in the internet. That my credit card number should never be in the plain text or encrypted with some very weak encryption algorithm before it goes out. And that's why we use things like symmetrical and asymmetrical encryption to ensure that. And that's how we are protecting data in motion. Data at rest, this is the data that's sitting on the servers of your website or of the e-commerce website. So how do I know that data is protected? That's just sitting there. Does anyone have access to it who shouldn't have access to it? And again, encryption. That we want to be sure that any data at rest is encrypted so that only the people who have the need to know have access to that data. And you see there's some areas that companies could be spending a lot more to improve data at rest as well as data in motion. Because, having analytics and correlation tools, yeah, that's important. Would I give it a 91%? No, because many times that is forensics. Something has already happened or about to happen, or happening before my analytics and correlation actually comes to play. So I'm already late to the game. If I'm just waiting on analytics or if I'm waiting on network defenses, because many times those things don't kick in until something has already happened. Now, and also many times network defenses and endpoint mobile defenses doesn't really protect your data from insider threats, right? Because many times insider threats, they are already sitting behind the firewalls of your network defenses and of your endpoint and mobile device defenses. So, ensure that your data is encrypted at all these points. Not that any of these are bad or any of them is the utopia, but having a balanced approach to security and privacy is what we're really talking about here, and that you're spending money at the right place. That your security budget is going to where it needs to be, that you got the right analytics tools, that you have the right type of data in motion defenses, the right encryption, that you have the right data at rest encryption, your network defenses, your firewalls, your intrusion detection systems, they're where they should be, and you have endpoint, security, MDM, mobile device management software that's running on your endpoints and your mobile devices. So really, you want to have a layered defense, defense in depth with respect to your websites, your e-commerce, and how you do that business. There's no one utopia. It takes a balanced approach. All right. So in this course, we covered a lot of things, right? We talked about e-commerce, some of the definitions, what it is, what it isn't, the digital marketplace, the different types of e-commerce and e-commerce models, B2B, B2C, C2C, how to plan and how to look at your e-commerce site. And really, we spent time on that security and privacy considerations. So as you think about this from an information systems management perspective, this is just one of the multiple facets of this career path that you need to look at to be sure that you're protecting the data resources, as well as the edges of the network as you provide services in a e-commerce or in an e-tailer environment. All right, guys, appreciate that. See you for the next class coming up.